Good day, everyone. I'm Durga Devi Annapurna Poniraja. My number matrix is 01 DKA25F1141. First, let me briefly explain about the importance of integration in real life. In civil engineering, integration is used to calculate. It's widely used in daily life. Integration is used to calculate area of irregular lands, volume of water in drainage system, and even knot distribution instructions. This makes it a very important mathematical tool for calculate design and planning.
Hi, my name is Kuzuinat Nina binti Kuatumali. My metric number is 01DK25F1142. So now I'm going to read the question. Given the graph of a curve with question y equal to 10x minus x squared minus 8 and straight line y equal to 10 minus x, the line and the curve intersect at a point A and B and O is origin. Determine A. The coordinate of intersection points A and B. B. The shaded area R is bounded by line y equal to 10x minus x squared minus 8 and straight line y equal to 10 minus x.
Hi, I am Tanjara Anupro Banteng. My metric number is 01DKA25F216. For this part, I will explain how to find the intersection point between two equations. First, we are given two equations, y equal to 10x minus x squared minus 8 and y equals to 10 minus x. To find the intersection point, we equate both equations because at the intersection, the value of y is the same. So we write 10x minus x squared minus 8 equals to 10 minus x. Next, we rearrange the equation into quadratic form. Then we factorize. So we get the two values of x, which is x equal to 2 and x equal to 9. After that, we substitute these values into the equation y. Into the equation y equals to 10 minus x. When x is 2, so y equals to 8. When x equals to 9, y equal to 1. Therefore, the intersection point are point A at 2, 8 and point B at 1 at 9, 1. This is how we determine the intersection point of coordinate. Thank you.
Now let's move on to part B. We need to find the shaded area of R. Between do this, we need to use define integration. The formula is integrate top function minus bottom function. The top function is 10x minus x squared minus 8, and the bottom function is 10 minus x. Now let's look at the solution of the question B. Integrate from x equals to 2 to x equals to 9. So if we put the top function and minus the bottom function. So when we integrate it, it will get negative x cubed divided by 3 plus 11x squared divided by 2 minus 18x. So when substitute 9 in x and minus substitute 2 in x, so we will get 343 over 6 unit square.
Hi, my name is Sitino Arisha binti Abdurrahman. My number metric is 01DKA25F1115. Now my part is conclusion, and I'm gonna talk about integration helps calculate the accurate area between curves. And so, to wrap things up, let's take a look at the big picture. Why do we spend so much time mastering integration? Well, as we've seen, its primary superpower is precision. Specifically, integration allows us to calculate the accurate area between curves, something that simple multiplication and division just can handle when shapes get complex. Now, You might wonder where this actually lives outside of a textbook. In the world of civil engineering, integration is a foundation tool. It's what's moved a project from a rough estimate to a safe reality. Let's look at three key areas where this math literally hits the ground. Now, first, line measurement. In the real world, property lines aren't always perfect rectangles. When land is bordered by a winding river or curved road, we use integration to find the exact square footage. Second, drainage and water flow design. To prevent flooding, engineers have to calculate the volume of water moving through irregular, irregular channels. Integration helps us design systems that can handle the pressure and flow of nature. And third, structure calculations. Whether it's the curve of suspension bridge of the weight distribution of a modern arch, integration ensures that every force is accounted for, keeping our structures standing and the public safe. And last, the conclusion. It's okay if you still feel like the student on the slide with a few question marks over your head. Calculus is a journey, but remember, every time you drive over a bridge or walk through a well-drained city, you're seeing the practical success of integration in action. Thanks for joining me for this session and thank you. Bye.